Next, I'm going to derive the molecular geometry from the electron domain geometry that we just learned. Okay, so pretty much I'm going to start with two electron domain geometry. So this is linear that we just learned. If linear electron domain geometry got the lone pair introduced to the structure, you are going to replace one of these. So this is bonding, right? So if I replace this with a lone pair, I pretty much can just replace that with lone pair. But what we are going to look at in terms of molecular geometry is that we are going to kind of like ignore this lone pair right here. So I'm going to actually take that out and just imagine that there is one lone pair right here. So molecular geometry without considering the lone pair, this is going to still be linear, right? Because it's look straight line, right, like this, right? So this is gonna be linear, and the bond angle gonna be still like 180 degree. Okay, so now what about when we have three electron domains? Okay, so when we have three electron domains, you are going to end up with the trigonal planar. The reason why this is called trigonal planar, again, because it's in plane, right? It's a triangle, it's a trigonal planar, right? Planar mean plane, right? Trigonal mean triangle, right? So it's the triangle in plane. Okay, so again, the bond angle of this would be 120 for all of these. Okay, if you introduce lone pair to this electron domain geometry, the molecular geometry will not be the same now. So I'm going to replace one of these bonding with the lone pair. Okay, so if I replace this with lone pair, when we consider the structure of the shape of the molecule, which is molecular geometry, you are going to pretty much kind of like ignore this lone pair that is here, right? And then looking at the overall structure. So the overall structure, since you replace this one right here with the lone pair, so what we have left would be just bent, right? It look like bent. So the bond angle here would be less than 120 because the effect of lone pair will push these two to be close together. Now, if you introduce one more lone pair, right? So if you introduce one more lone pair, that would be linear, right? Because right now it's just gonna be straight line like a linear. So 180 degree for this angle. Okay. Now, if you have four electron domain geometry, which is tetrahedral, so this is tetrahedral. Okay. You are going to introduce one lone pair. Doesn't matter which one you are going to introduce. It doesn't matter because this is I'm looking at in 3D, right? So but when I draw it on the paper, it's actually easier to remove from the top because it's going to be easier for you to see that it's going to look like a pyramid, right? If you remove it from the top, right, it's going to look like a triangle pyramid, right? So we call this trigonal pyramidal. Okay, so it looks like a pyramid. So same thing, it doesn't matter which one. So I remove the top one. So now what about, hey, can you prove that? Yeah, sure, I can remove this one too. Okay, if I remove this one, it's still going to be trigonal, it's going to be trigonal pyramidal. How so? Well, if I flip this, right, it's still gonna be trigonal pyramidal, right? It doesn't matter which one which one I take off, right? So same thing, if I take this one out right here, okay, it's going to still be trigonal pyramidal. Okay, so if you just flip it, right? So pretty much what you are looking at is you need to make sure that you understand, but the easiest way is to take out the top one so that way you see it clearer that this is trigonal pyramidal without having to rotate it. Okay, so this is introducing one lone pair. Okay, so would be from tetrahedral, introduce one lone pair would be trigonal pyramidal. If you introduce two lone pair, it doesn't matter which one you are taking away because it's still gonna give you bent structure. Okay, so whether you take off this one, okay, so that's gonna be bent, right? Or if you don't want to take off this one, you take off this one, it's still going to be bent as well. Oops, more difficult, it's still going to be bent. Okay, so it doesn't matter which one you take out, it's still going to give you the same molecular geometry for this one. Okay, so I'm gonna actually take this one out. Okay, so we are going from tetrahedral, right? We're going from tetrahedral. You are introducing one, so here we go. Let me actually redo this. So we are starting with tetrahedral. We introduce one lone pair, that would be trigonal pyramidal. We introduce one more, that would be bent. Okay, if you introduce one more lone pair, that would be what? it would be linear, right? So it would be linear. Okay, so next is when you have 5 electron domains. Okay, so this is 5 electron domains. Okay, so again, these 5 electron domains, we call these trigonal bipyramidal. Trigonal means the base is a triangle, okay, and then it's a 2 pyramid, top and bottom. Okay, so if you're looking at the base, so I'm going to tilt this. Okay, so if I tilt this, you will see that it's going to look like a triangle, right? 1, 2, and then 3 on this side. Okay, so if I flip it over, right, so it look like a pyramid on top, 1 on top and 1 on the bottom. Okay, this one is called axial, right? So this 2 is called axial. This position right here, this is called equatorial. Okay, so this is called equatorial. So this is 90 degree. Okay, so this is 90 degree, 90 degree, 90 degree. Okay, but if you flip it over, this would be 120 degree, 120 degree, and 120 degree, right? So those are the 2 angles that you need to describe. Axial would be 90, equatorial would be 120. Okay, so when you are adding lone pair to trigonal bipyramidal, you always need to add to the equatorial position first, which is this one right here. Okay, so it doesn't matter which one you are going to add. So if you start adding with this one right here, okay, what you are going to end up having is you will need to pretty much like have to rotate it, right? So this is going to look like seesaw, right? So it look like a seesaw. Okay, so this look like seesaw. Okay, so that means it's going from trigonal bipyramidal, add 1 lone pair would be seesaw. Okay, I'm going to add another lone pair. Okay, so I'm going to add another lone pair. If I add another lone pair, okay, so what you're going to end up having would be T-shape, right? And if I add 1 more lone pair, okay, so this is still equatorial position, right? If I add 1 lone pair, then it's going to be linear, right? So it's still going to be linear. Okay. The reason why we need to add onto the equatorial position, because equatorial position are further apart by 120 degrees. So that's why we are adding into the equatorial position. Now for octahedral, which is 6 electron domain, it doesn't matter which one you are adding because all of these has the same bond angle, which is 90 degrees. So it doesn't matter which one you add. Okay, so let's say that you add the top one. Okay. If you add the top one, it might be a little bit difficult to see, but pretty much it looks like a pyramid, right? So this is a pyramid, and it's have like a 4 base. Okay, so this is the 4 base right here, right? So this is a square base, so we call square pyramidal because it's a pyramid. Okay, so square pyramidal because the base is square and it looks like a pyramid. And the second lone pair we are going to add is going to be the opposite, right? So now instead of become a pyramid, now it's flat, right? It's in plane, so we call this square planar. Okay, if you introduce 1 more, okay, so if you introduce this, you introduce 1 more lone pair, you are going to end up with T-shape. Okay, if you introduce 1 more, it's better to introduce to this one, which is the opposite, right? So it's the opposite lone pair. You are going to end up with linear. Okay, so that would be all the molecular geometry that derive from the electron domain geometry by adding the number of electrons, the lone pair electrons.